Hello students, in the last class we discussed about the uh, batteries and different types of batteries. In that batteries we are discussing about the voltage charging and discharging curves. So in this class we will discuss about the important characteristics of our batteries. So when we are discussing about the batteries, what are the important characteristics we have to discuss here? There are three important characteristics of an accumulator or storage battery. Generally we have three. Accumulator and storage battery both are same. Namely, one voltage, two capacitor and three is efficiency. Voltage, capacity, efficiency are the three important points. First, voltage. Average EMF cell is approximately 2 volts. So that is generally the combination of number of cells will give one battery, generally 2 volts EMF. The value of the EMF cell does not remain constant but varies with the change in specific gravity of electrolyte. So it depends on the electrolyte. What is electrolyte? Electrolyte means a simple thing. So we have more number of batteries, but one battery is lead acid and nickel iron and lithium ion. So these are the chemical things. These chemical things are working. These chemical things are electrolytes. These will be converted electrical energy into chemical energy or chemical energy into electrical energy. So that specific gravity, this depends on the specific gravity of the electrolyte, comma, temperature. So temperature also affects, and the length of the time since it was last charged. So the last charging time also it is important. These are the things decides the voltage of the any EMF cell. What are the things? The EMF cell voltage will decide by one specific gravity of electrolyte and the temperature and length of the time since it was last charged. The EMF of the cell increases with increase in specific gravity of the electrolyte. So if the specific gravity is increases, automatically the EMF will increases, and vice versa. If it is decreases, that will be decreases. But increase in specific gravity of the electrolyte also causes increase in internal resistance of the cell. So we have a problem. If the specific gravity increases, EMF increases, but by increasing the EMF, the internal resistance of the cell also increases. Therefore, its value should not be in the 1.22 volts. Should not be in the 1.22 volts. So better to maintain this value 1.22. Best results are obtained with electrolyte for the specific gravity is 1.21 volts. So any electrolyte must and should be 1.21 volts. The specific gravity of the electrolyte is 1.21 volts. Otherwise, the internal resistance will be increases. If the specific gravity increases, EMF increases, but the problem is internal resistance increases. So to maintain that, always specific gravity value is 1.21 volts. The EMF of the cell, though not much but slightly increases with the increase in temperature. Generally, when we are increasing the temperature, the cell of EMF cell is not increased but slightly increases. The terminal voltage of battery is higher during the charge than during the discharge. Generally, when it is charging means when it is charging, the terminal voltage increases. Why increases? The current will be entering into the battery. That means creates a potential difference compared with the discharge. These are the points of the voltage. What are the points? Voltage is most important thing. First, the voltage will depend specific gravity of the electrolyte and the temperature, length of the time. And this specific gravity increases, the EMF increases, but when a EMF increases, internal resistance also increases. That will create the problem for the battery. That's why the specific gravity almost 1.21 volts. So whenever if you are increasing the temperature, always it is not increases the EMF, it is only 1.21 volts. The most important thing is terminal voltage during battery during charging is higher than the discharge. Next, second important character of the battery is capacity. The quantity of electricity which a battery can deliver during the single discharge until its terminal voltage falls 1.8 volts per cell is called the capacity of the battery. Generally, when it is charging, the terminal voltage is, when it is fully charged, that is 2 volts. Fully charged, the terminal voltage will become the 2 volts. Next, full discharge, and the same terminal voltage will become 1.8 volts. In the 2 volts of the difference, the total battery will be discharges. Right? Look at here. That's why delivered during a single discharge until its terminal voltage is 1.8 volts per cell is called the capacity of battery. This is called the capacity of the battery. The capacity of the cell is therefore the expressed in ampere hour and is equal to the, so generally the capacity of the any battery is represents with ampere hour. So this capacity units are ampere hour. Ampere is unit of the current in the battery. Hour is discharging time, unit of discharging time, how much of it discharges, right? And is equal to the product of the specific discharge current in amperes multiplied by the number of hours before the cell discharges to its specific extent. So per particular extent it has to discharge. So in that, the product of specific discharge current in amperes multiplied by the number of hours before the cell discharges to the extent. If ID, name itself ID, discharge current in the ampere, so generally you have to take I suffix D. TD is discharging time of the cell or battery in hours, so that is represents with TD. Then the capacity of the battery or cell is ID into TD. So better to take R, I suffix D into T suffix D. Understand? Simply the capacity of the battery is nothing but it is discharging time into discharging current. The units are ampere hours. This is the one of the important characteristics of the battery. Next, third important character of the battery is the efficiency. The efficiency of the cell can be given in two ways. Generally efficiency can be told in two ways. First, the quantity R ampere hour efficiency. The first efficiency is, it is named as the quantity R ampere hour efficiency. So in that, the ratio of output ampere hour during the discharging to the input ampere hour during the charging of the battery is called quantity R ampere hour efficiency. This is called the quantity R ampere hour efficiency. Simply, so efficiency is nothing but output by input, but the output here, what is input of the battery? Input means charging of battery. Input means taking the input. During the charging, the charging is represented in the capacity. Charging capacity is charging current and charging time. What is output of the battery? The battery output is represented in discharging process, giving the battery is output, that is discharging current into discharging time. So then the ratio of this IDTD is discharging output, and the ratio of this is input. Generally, what is output by input? Output by input is efficiency. but this is ampere hour efficiency. Another name is the quantity efficiency. Simple. Efficiency means output by input. Output is discharging capacity, input is charging capacity. Understand? That is called the quantity or ampere hour efficiency, where ID is, you know, that discharging current in amperes, IC is charging current in amperes, TD is discharging time of the cell or battery, TC is charging time of the cell or battery in hours. Okay, this is the one efficiency, that is ampere hour efficiency. Next, we have another efficiency, that is called energy or watt hour efficiency. Energy, what is the formula for energy? Energy formula is power into time. Power units are watts, time units are generally seconds or hours, depends on requirement. Here we are using the hours, so therefore watt into hour is called energy. So that's why energy, that's why that name is energy efficiency or watt hour efficiency. Right. Same thing here also, the output energy discharging through to input energy charging. Output energy discharging to input energy discharging. Okay, output means discharging, input means charging. Here the ratio of the output watt hour during the discharging to the input watt hour during the charging of the battery is called simply energy or watt hour efficiency, name itself of the battery. Why? Because we have output watt hour by input watt hour. So efficiency, watt hour efficiency equal to output energy means, output means discharging process, that's why discharging voltage, discharging current, discharging time, this is the output energy. And input energy is charging voltage, charging current, charging time, this is the input voltage, where VD is average terminal voltage during the discharging and VC is average terminal voltage during the charging. ID is discharging current in amperes, IC is charging current in amperes, TD is discharging time of the cell battery in hours, TC is charging time in our battery. Simple. We have a one battery will take the power from the source, this called as charging, it is called as input, name it as the input. And after supply is off, it will supply power to the load. So required any load means fan or bulb or anything. So this is battery. What happens? This process is called discharge, this is called the output. So in this time the terminal voltage, charging voltage and charging current and charging time is there. Here also discharging voltage and discharging current, discharging time is there. That's fine. So efficiency is simply, you know, that the output by input. What is output process is discharging process, input process is charging process. But here we are taking only the ampere hours, but here we are considering the voltage also. So this is the third important characteristic of efficiency. Generally this efficiency is two types. One is the quantity or ampere hour efficiency. The second one is the energy or watt hour efficiency. Understand? I think all of you understand about this. And these are the important characteristics of the batteries. That is, when we are buying the battery, we have to look at all these things. First one is voltage, second one is capacity, third one is efficiency. That efficiency is two types. One is ampere hour efficiency, second one is watt hour efficiency. Okay, I think all of you understand this concept. Thank you.